In this video, we're going to do sample questions from homework section 5.5, polynomial and rational inequalities. So they're all going to be different versions of the questions that you have on your MyLab. In particular, there's going to be a little bit of different numbers. So question 1 said solve the inequality 20 minus 4x is less than or equal to 8. Express your answer using set notation or interval notation and graph the solution set. So I'm going to minus 20 to both sides, and I get negative 12, and I'm going to divide by negative 4. So you get a positive 3, but remember when you divide by a negative number, you change the sign, and then x is greater than or equal to negative 3. So one way to write this is for all x, such that x has to be greater than or equal to positive 3. Or you write this starting at 3. You have to use the hard rigid brackets because it's including 3 with the equal sign, all the way to infinity. And infinity always has a parentheses. And then if we were to graph it, 3 would be here, closed circle would be here, or round or hard bracket would be here, and you go out. Okay, question 2 says to solve the inequality x squared plus x is less than or equal to 2 and graph the solution set. So first step is to make sure that you regroup everything to one side. Second step, find your roots so you can create your test values. So factors of 2 that give you 1, or 2 and 1. We're going to do roots, so I put equal signs here. Signs are different, bigger one's positive. I'm finding my roots, so I do my t-chart. So these are my test values, negative 1 and 2. Not negative 1, sorry, negative 2 and 1. So remember, this divides it into regions. Region 1, region 2, region 3. You want to pick a value in each region so you can test it. So we have made a chart. We can write our region here. We put our function that we're looking to test the signs of here. I basically just read it from here. And so in region 1, possible value that is less than negative 2 would be negative 3. So when I put negative 3 in here, I get negative 1 times negative 4, so it's a positive 4. Now you ask yourself, is this answer less than or equal to 0? It's not, so region 1 will not be one of my solutions. Now let's pick a number in region 2. Let's pick 0. 0 plus 2, 0 minus 1, that'll be a negative 2. Is that less than or equal to 0? Sure is. And then let's do region 3. Let's try x is equal to 2. 2 plus 2, 2 minus 1, and that'll be 4. So the only region that meets the inequality rule is going to be region 2. So that's anything in here. Now notice that it's less than or equal to 0. So that means it includes these endpoints as well. So our solution can be written in a few ways. If you're writing it in interval notation, it'll be including those test points, so negative, not test points, including those endpoints, so negative 2, 1. If you had to write it as a graph, it would be just like you see up there. It would be negative 2, 1, but with the harder brackets. And if you had to write it in set builder notation, it would be for all x such that negative 2 is less than or equal to x, which is less than or equal to 1. When I look at MyLab wants you to write it in interval notation and then to show the picture. Okay, so question 3 really just builds on question 2. The only difference is that it's a polynomial, not a quadratic. So everything is moved to one side, all the variables, so that first step is done. Second step, factor, so you can find your roots. So x squared is common to both. So when I find my solutions, or my bounds for my number line. We get x is equal to 0 and x is equal to 9. So we have, again, just 3 regions. We write our region out. We write our factored form. And we want the answer to be less than 0. It's less than 0, so it's not going to include the points, whichever direction they go. Okay, so let's pick something in region 1, and I'm going to pick -1. So I have -1 squared, -1 minus 9. That'll be a -10, and that works. So let's look at region 2. Let's pick +1. So that'll be 1 minus 9. That'll be a -8. So that works. Now let's pick something in region 3. Let's pick 10. 10 squared, 10 minus 9, and that'll be 100. That does not work. So we have 2 solution sets here. We have the region 1 and the region 2. But because it's not an equal to 0 in this here, it's just less than, you can't include 0. So when you write your solution, anything up until 0, so it's -infinity to 0, along with anything from 0 to 9. You can't go from -infinity to 9, and we say it's the union of that. Get to question 4. First thing you need to do is group everything to one side. You didn't have to do that in question 3 because it was already there. Take out your GCF. So that'll be 2x squared, so that leaves you x minus 2 for your factored form. Now we're going to find our roots. So we set each equal to 0. And then we draw our number line and find our regions. 3 regions. And we write our table. And now we want our answers to be greater than 0. So for region 1, let's pick x is equal to -1. So that'll be 2 times -1 squared, -1 minus 2. That'll be 2 times -3, -6. That's not greater than 0. Let's look at region 2. Let's pick x equals 1. So we get 2 times 1 squared, 1 minus 2. That'll be 2 times -1, -2. That is still not greater than 0. And let's look at region 3. Let's do x is equal to 3. That'll be 2 times 3 squared, so that's 2 times 9, 18. And 3 minus 2 is 1. So +18, that is greater than 0. So region 3 is my only solution. It's greater than 0, so it doesn't include the endpoint. So it's 2 to infinity is your solution. So question 5 really already did both step 1 and step 2 for you, which is, you want to make sure that you have everything on one side, all your variables, and you want to have it factored. You just have to find your test point, like your intervals now, or your roots. So the roots will be 1, 5, and 6. So notice how many regions you have. 1, 2, 3, 4 regions. More than before, right? So we write our region, we write our factors, and then we look to see what the result's going to be. Picking a number in the region 1, let's pick 0. So we'll have -1, -5, -6, that's a negative 30. And that will be less than or equal to 0. In region 2, let's pick x is equal to 2. So we have 2 minus 1, 2 minus 5, 2 minus 6. So that's 1 times negative 3. So that's negative 3. Negative 3 times negative 4 is a positive 12. That does not work. Let's look at region 3. Let's pick x is equal to 5.5. 5.5 minus 1. 5.5 minus 5. 5.5 minus 6. So this will be positive, positive, negative. I don't really care about the negative, right? And so this one works. And then let's pick 4. Let's do x is equal to 7. And that'll be 6 times 2 times 1. And that's positive. So the only regions that will become less than or equal to 0 would be regions 1 and 2. And it actually has to include those endpoints, because it's got an equal sign. So these guys right here. So you want from negative infinity to 1, 5 to 6, 6 to infinity, but you want to include them, except the infinities, right? So I put a hard bracket here, hard bracket here, hard bracket here, hard bracket here. But now notice that since these are hard brackets, I actually can skid through both of them. And so the answer is negative infinity to 1 hard bracket, and then 5 all the way to round bracket infinity. Gosh, why did I include section region 4? Right? Was that concluded? Ugh, silly me. So no way. This guy's not included. This guy's not included. I'm not really sure why my brain slipped there. But 6 to infinity is not included. So it's just this. Okay, number 6. Solve the inequality algebraically. Same idea. So everything, all the variables are pushed to one side. You now want to factor. So when I factor out a GCF of x, I'm left with this. And then I look at factors of 15 that give me 2. It would be 5 and 3. The signs are different. The bigger one is negative. Then I look for my roots. So one root is 0, 1 is negative 3, and 1 is positive 5. This creates my test regions. Put them in order on a number line. And you have 1, 2, 3, 4 regions. Region, x plus 3, x minus 5, and we want the result to be less than 0. Okay, so in your first region, let's try x is equal to negative 4. So you have negative 4, negative 4 plus 3, negative 4 minus 5. So that's going to be negative 4, negative 1, positive 4, and negative 9 is positive 36. Sorry, negative 36. Because negative times negative times negative is negative. Okay, let's look at the second region. Let's do negative 1. So negative 1 plus 3, negative 1 minus 5. Negative 1, positive 2, so negative 2, and negative 6 is a positive 12. Region 3. Let's do positive 1. 1 plus 3, 1 minus 5. 1 times 4 is 4, times negative 4, negative 16. And region 4, let's do x is equal to 6. 6 plus 3, 6 minus 5. And that's going to be 6 times 9 times 1. And that's a 54. So So now you want your results to be less than 0. So those are your negatives. So that's region 1 and 3. There's no equal sign. So it's open circles or rounded brackets. So your answer is negative infinity to negative 3 with region 3, which is 0 to 5. Okay, so let's take a look now at a polynomial where you have a denominator, which this takes this one extra step. You have a rational function, which means you not only want to look for where your roots, solutions, x-intercepts are, but you also want to look where the denominator is equal to 0, because that you can't have, which also becomes a partition on that number line. So remember, your steps is to first set the numerator equal to 0, and then the denominator equal to 0. So we have x plus 9 equals 0. In this case, it's linear, so it's very easy to get that result. So these are our two tests. They partition for our tests. So we have negative 9 and 5, and we have 3 regions. So in region 1, we could pick negative 10. So we have negative 10 plus 9 all over negative 10 minus 5. So that's going to be negative 1 all over negative 15. So it's a positive 1 over 15. In region 2, we could pick 0. That would be 9 over negative 5. And then in region 3, we can pick 6. And that'll give us 15 all over negative 1. So we get a positive 1, sorry. So we get 15. You want the answers to be negative, and that's only region 2. It doesn't have an equal sign, so it's just from negative 5 to negative 9 to 5. All right, so number 8 wants you to put your intervals in. So it's a little of the work we had done, only now they give you like a chart. So set your numerator equal to 0. And then set your denominator equal to 0. Denominator equal to 0 is easy. Numerator, you get positive 5 and negative 5. So we do our number line, and then we'll fill in the chart. So just be patient. So we have negative 5, 0, 5. Region 1, region 2, region 3, region 4. We're going to fill in the chart just after we do like we always do. You know your region. You have your expression. And then we're going to talk about our signs. So let's pick a number in the region 1. Let's do negative 6. We'll put negative 6 in there. We're going to get negative 11, negative 1. So that's going to become a positive 11 all over negative 6, so negative 11 over 6. Let's talk about region 2. Let's do negative 1. Negative 1 minus 5, negative 1 plus 5, negative 1. So that'll be a negative 6 times a positive 4. That's negative 24 all over negative 1. That's a positive 24. So about region 3. Let's do x equals positive 1. So we have 1 minus 5, 1 plus 5 all over 1. That's negative 4 times 6. That's negative 24. And then let's talk about region 4. That would be x is equal to 6. So we have 6 minus 5, 6 plus 5 all over 6. So that's 1 times 11 all over 6. Now we want the signs to be less than or equal to 0. That's negative. So that'll be region 1 and region 3. So now let's talk about what this picture says. It says put the interval in and then put the signs. So let's input it in. The first interval goes from negative infinity to negative 5. And we saw that interval was negative. And the second interval was negative 5 to 0, and we saw that was positive. Then 0 to positive 5, and we saw that that was negative. And then 5 to infinity, we saw that was positive. What's the solution? Well, we said the solutions were these guys. So the solution went from negative infinity to negative 5, including it, and then positive 5 to infinity. Then it says type your answer in its notation, use interpretation, and then underneath that here, you just had to actually put the, like for interval 1 it would be negative, for interval 2 it would be positive, negative, positive. Just be careful that when you write your intervals in here, everything is rounded, brackets, but when you write your solution here, it has the included brackets because 5 is included in the solution. All right, question 9. So first thing is you bring everything to set equal to 0. And then we want to find where numerator is equal to 0, denominator is equal to 0. So, or just the whole function is equal to 0. So let's set the whole thing equal to 0 first. And then we're just going to set the denominator equal to 0. So 11 is one of our partition numbers. And here, if I did keep it so that way it was equal to 1 and I cross multiplied, I would have x plus 6 is equal to x minus 11. And when I subtracted to x's on both sides, I'm going to get 6 equals negative 11, and that means there's no solution. So the only number we can use on our number line is this 11. So we only have 2 regions. Okay, so we're going to pick a number in this region here. Let's pick 0, and let's pick 12. So I'm going to have 6 over negative 11 minus 1. That's going to be a negative number. And in region 2, I'm going to have 12 plus 6, so over 12 minus 11 minus 1. So it's going to be 18 over 1 minus 1, which is going to be 17. You want greater than 0, so that's region 2. It's greater than or equal to. However, 11 is where you can't have, because that's the restriction on the domain. So normally you would say, oh, it's going to be 11 to infinity, but you can't, because 11 can't be included. So it's 11 to infinity as your solution. Lastly, question 10. Bring the 2 over. This will be what we use for our test part. So now we're going to look where the whole function is equal to 0. Then we look where the denominator is equal to 0. So negative 5 is one that we can't have as a solution, but it actually ends up being a boundary. And then when we solve this guy, we'll bring that 2 back over, cross multiply, and solve. So if I minus the 2x to the other side, I have x. I add the 5 to the other side, I get 15. So now that means I have 2 numbers to put here, negative 5 and 15. I have 2 regions. 3 regions, I'm sorry. And so now we do our region study. So we look at our region. We look at 3x minus 5 all over x plus 5 minus 2, and we want to see when it's going to be 0. So let's pick, in region 1, let's pick negative 6. So we have negative 18 minus 5, will be negative 1, minus 2, that's going to be a negative number. In region 2, let's pick 0. So I have minus 5 all over 5 minus 2. It's also going to be negative. And in region 3, let's pick 16. So we have 3 times 16 minus 5, 16 plus 5. That's definitely going to be positive. So we want less than or equal to 0, so region 1 and region 2 win. Only thing is you can't go straight through because at negative 5 there is a, it's not defined there. So your answer is negative infinity to negative 5 with negative 5 to 15. Now, do you include 15 or not? Well, it's equal to. So you do. Let's just check our work one more time. Let me check this negative 6 real quick. This will be negative 23. Holy smokes. So if we take a look here, this is negative 23 over negative 20 over negative 1, so it's a positive 23 minus 2. That is definitely positive. So I made an error here in my arithmetic. So the only solution is region 2, because that's the only one that gives you a negative number.